So an important part about solutions is their concentration. And the word concentration is an expression of how much solute is in our solution. So see how much solute is dissolved in your solution. So when we say concentration, that's what we're talking about. There's many different units. We're going to look at two in our text, but depending on the field, the situation, there can be a variety of concentration units that are used. Now, oftentimes, commercially, they just may use qualitative expressions, which means they just use words to tell us what's happening. And it could be said like you have a dilute solution and a concentrated solution. It's not uncommon now to purchase concentrated solutions, and then when we want to use them, we add water to make them dilute. So in general, when we see a dilute solution, that means it has less solute, okay? A concentrated solution would have more solute. So concentrated has more solute in the solution, and dilute has less solute. And this works perfectly for household things. Like I have a floor cleaner that I use, and it's concentrated, and you read the directions and it says fill the cap to this line, then pour it in the bucket and add, I don't remember how much water, because honestly, I just now pour that cap full in, and then I just wait till I think the bubbles are good, and then I go with it, right? That's fine for my floor. If I mess up, like if I add too little water, it might be sticky. If I add too much water, it might not clean well. But in the big picture, it's a situation where just using dilute and concentrated would be appropriate. But in lab, in medicine, in industry, you have to have numbers, because it's the almost there really doesn't do it. So we're going to look at two concentration units that are I didn't spell quantitative. Let me correct it here. I'll have to do it on my slide. There, we need a T. Quantitative expressions of solution. So what we're going to use is numbers. Now, the same idea, concentration, does tell us how much solute is in our solution. So qualitative just uses like dilute and concentrated, so less and more. And quantitative descriptions are going to use our numbers to tell us how much solute. And we're going to do 2 units of concentration, mass to mass percent, which is a pretty common one in industry, and then molarity. There's several percent concentrations, but your text just focuses on mass to mass. So in this video, I'm just going to do mass to mass, and then I'll do another video for molarity. So mass percent concentration is when we compare the mass of the solute to the mass of the solution. So here is the equation, and this is not given to you. So if we look at this one, we just take the mass of the solute, divide it by the mass of the solution, and then multiply by 100 since it's a percent. Now, in terms of actually doing it, if they give you the solute, that you're going to take the mass of the solute, and then the solution includes the solute and the solvent. So if they do not say solution, and instead they give you the solute and the solvent, as long as it's in mass, it's additive. Volumes are not additive, which means you can't, if I had 10 milliliters of water and 10 milliliters of ethanol, it might not make 20 milliliters. That's because the liquids can kind of get closer and farther apart from each other. But masses don't do that, so masses are additive. So we can just add the 2 masses to get our solution. So let's try an example where they ask us to calculate the mass percent. So here it is. It says calculate the mass percent of sodium chloride in a solution prepared by dissolving 5 grams of sodium chloride in, 97 grams of water. So this is the solute, and this is the solvent, right? That doesn't say in solution. So here's water. Okay, that's our solvent. All right, so the percent of mass to mass is going to be the grams of the solute divided by the grams of the solute plus the grams of the solvent. I'm putting parentheses because in your calculator, you want to times 100. So it is 5 grams of sodium chloride divided by 5 plus 97 times 100. I'm getting my calculator. So that would be 5 divided by 5 plus 97 times 100. And I get 4.90 to 3 significant figures, which seems reasonable. 90% mass to mass. There's in percent units, they don't put the units there. They just put what you're comparing. So there's mass on the top and mass on the bottom here. So that's how they tell you what units you're using. This number, just to confirm, significant figures, 5 plus 97 would be 102.0. So see, that has 4 significant figures. So 3 would be appropriate. So this solution is 4.90% of sodium chloride. Okay, so that's how we calculate if we want to know the percent. If they want us to know the concentration, they'll give us the mass of the solute, they'll give us the mass of the water or the mass of the total solution, and we can calculate the mass percent. What I want to think about now is, what if they give us the percentage and want us to calculate either the amount of solute or the amount of solvent? And your textbook sets it up with ratios based on the information given. So this is the next slide. These are factors based on what we just did. So it says we can write several unit factors based on the previous problem. And remember, I just calculated it's 4.90% mass to mass. So we could write here a ratio, and this is based on the percent mass to mass. So percents always tell us out of 100. So if our concentration we calculated on the previous page was 4.9%, it means that we have 4.9 grams of sodium chloride in 100 grams of the solution. So we can set that up as a ratio, and we can flip it depending on whether we're trying to cancel sodium chloride or the solution. Now, the other two would really be if you needed to calculate how much water has anything to do with the water, your solvent. So in this example, this ratio, this is based on what they gave us, that we put 5 grams of 5 grams of NaCl in 97 grams of water. So that's the ratio of the solute to the solvent. Okay, so that's that one. So we could use that ratio. And then the final one, this is 95.1 grams of water in 100 grams of solution. So you think, well, what? Well, we think about it. If we have 4.90 grams of water in 100 grams of solution. If you subtract this from 100, you get 95.1 grams of water. So if you have 100 grams of solution, the 4.9 grams, which we got from the first one, is that's the solute. So the remaining must be the water. And we get this, which compares water to solution. So these are three factors. And you know, every time we do unit factors, what we're doing is like conversions. So let's look at a problem and see like, okay, so what kind of unit factor? What am I doing? Because this is just all the kinds of unit factors we can get. Well, a problem would just use one unit factor. So it says, what is the mass of a 5 mass to mass percent solution of dextrose containing 25 grams of dextrose? So here's what I know. If you give me the concentration, I know that I have 5 grams of dextrose in 100 grams of solution. Right? That's what the percentage tells me. That is what this right here tells me. I have 5, it's mass to mass, grams of the dextrose in 100 grams of solution. Why did I pick 100 grams of solution? Percentages are out of 100. So 5% would say I have 5 grams of dextrose in 100 grams of solution. Now, I look at what they gave me. They said, okay, you have 25 grams of dextrose. How much solution do you have when you have 25 grams of dextrose? Well, I can use this up here. And I can set it up where the 5 grams of dextrose is on the bottom and the 100 grams of solution is on the top. Then what happens is the grams of dextrose cancel out and I will solve for the grams of solution. So I say 25 times 100 divided by 5. And I get the answer of 500. So I have in 500 grams of solution, 25 grams of the dextrose, if it's 5%. Now, there's a second way. This is what I just did, and you can watch it again. This is using the ratios, in this case from the concentration. On this particular problem, because they're asking for solution and not water, I can also solve it using algebra. Personally, I like using the ratio, but it takes some practice to feel comfortable. So some of you might feel better using algebra, so let's try it. What I know is I have an equation. And that is the percent of the mass is the grams solute over the grams of the solution times 100. And so they're asking me to find this. So I plug in the 5. And I have 25 grams on the top. And the grams of solution, I'm going to put X. And then this, I'm going to change this to a dot because I don't want to have two X's, okay? So I'll change this one up here to a dot too. So anytime you have something you're solving for that's in the denominator, get it out of there fast by cross multiplying it to the other side. So it'd be x times 5 equals 25 times 100. Now 25 times 100 is a number. You can do it. I usually rearrange. So now I need to get the 5 back to the right-hand side. So I'd say x equals 25 times 100 divided by 5. And I get the same answer, 500 grams of solution. So I feel like if you can practice using the ratios, the factors, the unit factors that we get from the equation, it is simpler. If you can learn how to use those, it really simplifies the math when you look at the previous page compared to this one. But I know for some of you it's hard to think in unit factors, and so if algebra is a better way for you to work it through, then this is how you could do it with your algebra. Now there's practice problem. I have both practice problems in the work, on the worksheets, as well as homework. So I want you to try to get to it, and then let me know if you have questions so I can help you figure out what's going on.